This is video number 7 in the rates and equilibrium topic. It's AQA GCSE chemistry and it's part of both dual and triple award courses. I'm going to recommend, as always, that you pause as you go and have a go at the activities for yourselves. In this video, we're going to look at reversible reactions in the context of energy changes that take place within them. And there's a practical that's starting to be highlighted here, where we're going to take some hydrated copper sulfate crystals, that's blue copper sulfate crystals, and we're going to heat them. The method is really simple. We're going to gently heat a few crystals of the copper sulfate, and then once they have changed from blue to white, we are going to allow them to cool, and then we are going to add a few drops of water. Have a think about what observations you would make. And actually, there's a lot of information already provided here. The blue crystals become a white powder when you heat them. We'll talk about why in a moment. When we added a few drops of water, bearing in mind this is a reversible reaction, you would potentially get some blue crystals. However, it's equally likely that those crystals might dissolve in the water that we're adding, so we would end up with a blue solution formed. So what are we actually looking at here? We'll have a go at writing the equation based on the information here. So we're told that we're starting with CuSO4.5H2O. This is a solid crystal. This water is trapped inside the crystals, and that is going to break down into CuSO4, which is solid, the white powder, and we're going to make 5 moles of H2O. Bear in mind we've been heating it, so that is likely to be a gas. But there's an error on this page, and the error is this arrow. We're going to get rid of it because this is a reversible reaction, and as we are told, remember that this is a reversible reaction. So I'm going to put my reversible reaction arrow in. Let's move on. Which do we think is exothermic and which do we think is endothermic? Now, actually, you could have been asked either of these first, but we know the forward reaction, we know the backward reaction is exothermic. How do we know that based on what we've seen? Well, for the forward reaction to happen, we had to provide that heat energy, and we were breaking things apart. And breaking things apart is an endothermic process. So the backward reaction, where we're putting things together, would be exothermic. The forward reaction took heat energy from the surroundings. Again, a reminder, we know that because we were breaking things apart. That was spoken about in the previous chapter in quite a lot of detail. So looking at it from a slightly different perspective, the forward is endothermic because energy had to be provided to break the CuSO4.5H2O into the copper sulfate and water molecules. Breaking a bond is endothermic, making a bond is exothermic. And that takes us to the end of this video. Thank you for listening and goodbye.